Hello friends, welcome to my channel. So today we will see end-to-end implementation of Snowflake streaming on a real project requirement. The prerequisite for this video tutorial is that you should already have a Kafka setup in your system. You should be aware of basic terminologies being used in Kafka. For example, what is a topic, event, publisher, subscriber, and broker. And you should have a Snowflake account which is active. If you do not already have the Kafka setup, if you are not aware of the basic terminologies in Kafka, you can go to my previous video in which I demonstrated end-to-end setup of Kafka in the personal system, and I also introduced in brief what are the different terminologies like what is a topic, event, publisher, subscriber, and broker. I will add the link to that video in the description of this video so that you can go there, complete the setup, and come back to this video to see the demonstration of Snowflake streaming. Now, before we go to the implementation part, let us understand what is a real project requirement we have today. So, suppose you are working for a retail chain store which has its store across the world, and suppose the client comes to you with a requirement that for a particular region he wants to see the transactions happening or the transaction summary happening at the different stores in a particular region in real time. So the scenario is something like that in a particular region you have multiple stores and client wants to see what is the transaction activity is happening in those stores in real time. So what we will do, we will need to store the transactions happening at these stores in real time into some central repository through which we can develop the reports. Here for the central repository, we are using the Snowflake data warehouse, and for real-time data ingestion, we will be using Snowflake streaming feature along with Kafka connector. So what will be the architecture of this solution? So this will be the architecture of this solution. On the left side, we have multiple stores which exist in the same region. We will have our Kafka setup already, and we will have a defined topic to which all these stores will be publishing their events. Now, events in this case will be the purchase transactions. All these events will be stored in on the brokers of the Kafka servers. We will also have our Snowflake Kafka connector, which will keep listening to these events which are coming to this Kafka topic, and based on the configuration we provide to it. For example, let us say we want to store all the events which are generated in last 60 seconds into our data warehouse. It will keep on pushing all the events in last 60 seconds to our Snowflake data warehouse. Now, how does it work behind the scenes within the Snowflake data warehouse? So what does it do? Actually, the Snowflake connector will accumulate all the events which has been published in last 60 seconds into a data file, and it will push this data file into a Snowflake stage, and then it will trigger a pipe automatically which will load the data from this file into our target table. Now the good thing is that all of this preparation, data file, stage, triggering the pipe, and loading the data into the table, this all happens automatically. We do not need to be worry about any of these. So Snowflake will create all of these objects internally. So now let us see the implementation part. So before we go for Kafka connector setup, we need to prepare our Snowflake schema. Usually you can use the account admin for demo, but in real projects, you always have a defined role and user to perform these ingestion activities. So here in this case, we will use analytics database and Kafka schema, in which we will create a table where data will be ingested in real time. We will use the user Kafka Connect user and also the Kafka Connect role, which will have the different privileges. Now, what are the different privileges we need? Because the Kafka connector at the backend needs to create this stage, file, pipe, and table. So all these privileges are required. So here are the different privileges we are giving to it. On the Kafka schema, create table, create stage, and create pipe privileges. In the next step, we are simply assigning this role to the user as well as security admin. And here we are simply setting the Kafka role as a default role for Kafka connector user. To save the time, I have already done this setup in my Snowflake account. So here you can see I have analytics database already, and within the analytics, I have Kafka schema already, and my user is also created. So the next step is that we need to set up Snowflake Kafka connector. For that, first we need to download the Kafka connector jar file. For that, we can go to this URL. You can also go via Snowflake website. So if you put Snowflake Kafka connector in Google, it will take you to the Snowflake website. From here, you can go to installing the configuration of Kafka. Then you can go to this section, installing the connector. If you scroll down, it will show you the Maven repository link. And here you can go to this link. We need to download the connector for Kafka. So you click the Kafka connector. We can use the latest version. Click on this. Here you can download the jar file. So let us download it. So the download has started and it will be downloaded to the downloads directory. So let's go there. If I go to my downloads directory, my Kafka connector jar file is downloaded. The place where I need to put this jar file is the libs directory. So I can copy this. I can go to my Kafka directory, libs, and place it here. So the next step is that we need to update the connect standalone properties file. Now all the properties file are in the config directory. So if we go to our Kafka directory, inside config, we have all the properties file. Which file we need to update? We need to update the connect standalone properties file, and the section we need to update is plugin.path. So let us open that file, connect standalone.properties file. Now here you will see that this path is commented. We need to uncomment this path and need to put the path where we copied our Snowflake Kafka connector jar file, which is libs directory. So I already have this path here. This is the path which we need to place. You can put this path and save it and close it. The next step is that we create the private and public key. So if you already have a Git installed, you can use a Git bash to create the private key and public key. We will be using private and public key authentication to ingest the data via Snowflake connector. So you can open the Git bash here. In the Git bash, you can go to the directory where you want to store the private key and public key file. So I can go to cd desktop. Inside that I have keys file, keys directory. Here I can generate my public key and private key file. So this is the command to create the private key. If I simply paste this command, this will create a private key file. If I go to my keys directory, I can see this private key has already been created. Now I would also need a public key corresponding to this private key. So this is the command to create the public key. Here if you see, this is OpenSSL command. I am using the private key which I has just generated. Be mindful of the name and the location, and then I am generating the public key and I am putting it into rsa key.pub, that is public file. So if I enter, my public key file is already generated. So I have my private key as well as public key. We are going to need these keys, so let us simply open them. Okay. So as a next step, what we need to do is we need to configure this public key for our Snowflake user, which we are going to use. In our case, this is Kafka connector user 1. So we need to alter the user and set the public key. So I will simply copy it, go to the Snowflake, and here we need to put the public key, which is open here. So .pem file is the private key and .pub file is the public key. So we will simply copy this public key. Be mindful that you do not include this begin and end section or any additional spaces. Otherwise, you will not be able to use this. So let us simply paste it and run this. So my user is altered. We can also check this DESC user, Kafka Connect user. If you go down, your public key is set. Now, suppose you want to test whether this key pair authentication is working or not. So as a next step, what you can do is you can verify this. All you need is SnowSQL setup in your system. So you can give the account identifier, username, and then private key path to your private key to establish the connection. So let us run this command into command prompt. I already have NoSQL installed. If I run this, yes. So I am inside the data warehouse Snowflake account. So this ensures that my key pair authentication is working perfectly. Okay. So as a next step, what we need to do, we need to prepare a configuration file or properties file for our Snowflake Kafka connector. So these are the mandatory attributes which we need. So we can simply prepare them. So the simplest way to create a properties file is that you can go to the config directory. So all the properties files are always stored in config directory. Simply copy any properties file and then rename it to Snowflake Connect. We can see that this is the name here. Ensure the name to be exactly this, because if this name does not match with the file name, our connector will not be able to find the file. So this should be the name of the file. You can simply open this sfconnect.properties file into the Visual Studio Code. Simply delete everything and let us paste what is the configuration we need our connector and modify these values. So connector class will remain same, task will also remain same. Topic, this is the topic where all these stores will be publishing their events to, and we will be listening. So this topic needs to be a unique topic name. So let us say topic regional transaction real time. Now you can configure the same properties file for multiple topics here. If you have multiple topics, you can give the configuration for a particular topic which table should get loaded. You can give multiple combinations using the comma separator. In our case, we will be using only one. We need to give the topic name to which this connector will be listening and the corresponding table name to which our data will get loaded. So let us say this. In the beginning, it is not required that this table should already exist, because if it does not, Snowflake or this connector will create it automatically. The next parameter is the record count, time and bytes. These three combination works in conjunction, like when to flush or when to push the data from Kafka connector to the Snowflake data warehouse. So either of this condition is true, either records accumulated or events got accumulated is more than 10,000, or time passed is 60 seconds, or total amount of data which has been accumulated is more than 5 MB. So whenever one of these conditions satisfied, our connector will push the generated events into the Snowflake table. Now here we need to provide the URL. Now one note here while you provide the URL. Like in this case, I am logged into my Snowflake account and I have this URL. If you try to give this URL, it is not going to work. You will get that invalid Snowflake URL given. So what you need to do is you need to go to Snowflake account. Here at the bottom, you will see your credentials, your username and everything. And if you hover on this active account, you will see two options, whether to copy the account URL or to copy the account identifier. We need to copy the account URL from here. Always hover on the active account, which is highlighted in blue. So if I copy this and then I paste it here, This URL we need to put. Now HTTPS is optional. Whether you can keep it or remove it, it does not matter. But let us remove it for now. Now what is the Snowflake username? We have the Snowflake username already. So we will use this. The Snowflake username in our case is Kafka connector user 1. This is our username. Now we need to provide the private key. So we already have this private key here, but notice one thing, that this is a multi-line private key, and in Snowflake connection dot properties, the private key expected is a single line private key. So one easy way is to use an online tool to remove the return characters. So we can simply use any online tool, remove line breaks online. So we can use this link. So if you just simply paste the key here and choose this option, remove all line breaks, and then you remove all line breaks, here you will be getting a single line private key. So now you can go here and paste this in your sf connect.properties. Here you can see that it is a single line properties file now. Now you need to give the database name. So in our case, it would be analytics. Let us simply copy it from here. Analytics, and schema will be Kafka schema. Converter, converter and value converter will remain same. Name is important. For every instance, this name has to be unique. So let us give it a unique name. So Kafka regional transaction ingestion ingest in real time. Let us give this name. Okay, our properties file is ready now. This is the most important step in establishing this Snowflake streaming or Snowflake streaming implementation, because if this properties file is not prepared with notice, you will be facing some issues. So now our properties file is ready. The next step is that we start our Zookeeper service. So we can go to our window PowerShell. I'm just reiterating that if you see the path not found error, you need to set your Java home variable. I have already set for this session, so I can simply start my Zookeeper service. It may take few seconds. Next, we need to start our Kafka server in a separate session. Okay. Once our Kafka server is up, we need to create a topic. Now, what would be the topic name? Same as we had provided in our configuration properties file. So let us simply open that again. And this is the topic name. This is the topic name which we need to create. So start your producer here. We need to replace this. Let us create a topic first. In the next session, now our topic is created. We can simply create a publisher just to validate whether everything is working fine or not until here. So this is a publisher who will be publishing events to this Kafka topic. Oh, sorry, this is a consumer. Let us create a publisher in next slide. So this is a publisher. So publisher is created and consumer was already created. So let us simply push something, some message. We are receiving the events in real time. So we can simply cancel this session. The next thing we need to do is start our Snowflake Kafka connector. So Snowflake, to start the Snowflake Kafka connector, we need to use the connect standalone.bat file. We need to provide two properties file. One is connect standalone properties file, where we have given the path for our library or Kafka connector, and also the SF connect properties to consider all other configurations. We can start our Kafka connector. If there are any issues with private key, public key, or database not found, or wrong URL, anything like that, you will get error here that you will not be able to connect or use the connector. But in our case, seems like everything is working fine. So what we need to do is we need to start publishing events to our topic. So for that, I will be using Python programs. So we need this topic here. So I have two different publisher programs. These are very simple programs in which I'm simply creating a publisher which will be which will be pushing the messages to this Kafka topic, and the message will be a simple set of attributes in a JSON format: publisher ID, publisher name, address, transaction ID, and transaction amount. So for first publisher, it will be like st1 the ID, and it will be for store 1. In the second publisher program, it will also be publishing to the same topic, but the publisher ID will be st2 and the name will be store2. So in Kafka, this is a very great feature that none of the publisher has to depend on each other to publish the messages. So let us simply start our publisher. Okay, our publisher has started and it is publishing a message every 0.4 seconds. Sorry, publisher one is posting a message every half second. Let us start another publisher. So here in another terminal, I need to start publisher2.py. So this is the another publisher st2, which is pushing the events to this same Kafka topic. Now if I see my consumer, let us say this consumer, to see what are the different events which are coming to this Kafka topic. I can see that the events are coming to this topic like one or two events every second, or maybe four or five events every second, according to according to the configuration. Now let us go into the Snowflake and see whether a table has been created there or not. Worksheets. So if I go here into the analytics schema, analytics database, Kafka schema, tables, I can see that a table has been created, topic, regional transaction, a real-time table, and a stage will also got created for the same to ingest the data into this table with the same name, Snowflake Kafka connector, Kafka regional transaction. Okay, and a pipe will also get created to push the data from this stage into this table. So let us see if there is any data coming to this table or not. So we can see data is getting pushed. So by default, Snowflake Kafka connector creates a table with two columns. One is record metadata and what is record content. So record content is the actual message which is coming within the event, and record metadata is the data about the event. These both data types are of variant data types. So right now we can see how many records. Right now we have 207 records within this table. So our Kafka connector will keep on pushing data every 60 seconds into this table. So now we have 477 records. So we are receiving all the transactions almost in real time, within a lag of 30 seconds to 60 seconds into our Snowflake data warehouse. As a next step, what we can do is to prepare a summary or report out of this table. We can simply create a dynamic table. So for example, we have here a dynamic table which will simply parse this JSON data which we are receiving into different fields like address, store name, store ID, store name, what is the total count of a transaction for a particular store, and what is the total transaction amount. We have to provide the table name though from here. So if I create this dynamic table, my table is created. Now all I can do is simply use this table for reporting purpose. The good thing is the dynamic table will keep on automatically refreshing, and it will also be a incremental refresh. So as soon as data gets added to my source table, that data will get reflect into my dynamic table. So I can simply run select star from this order by one. So I can see right now for store 1, 361 transactions are received. For store 2, 386 transactions are received. And my program is still running because I am continue to receive the transactions. So within a period of maybe one time or 70 seconds, this stats will keep on updating. And that's how we can show the transactions, summary of the transactions happening at the regional stores in real time with a lag of like 20 to 30 seconds. That's the acceptable lag even for the real time systems. So if I run it again, 361, 386, if I run it again, it may take from 50 to 60 seconds. We can check how many records now we have in our table. In our table now we have more than 1000 records. If I run it, okay, still it has not got refreshed. So until it gets refreshed, let me explain the internals of dynamic table. So when we are creating the dynamic table, the most important thing is this target lag. That is, after how many seconds or minutes you want the underlying data to get refreshed. So right now you cannot give less than 60 seconds. So at least after 1 minute, the data will get refreshed. You need to also provide the warehouse, which warehouse you need to be used for refreshing the underlying data, and then a select query. Select query can be any complex level of query. Now the good thing is that the refresh is always incremental. That means it does not reprocess already uh, updated data. Whatever new data has come in the underlying table, it only considers that data and refreshes the dynamic table. Now if I run it again, so now I have store 1 600 and store 2 686, which were earlier in 361 and 386. So this is an end-to-end implementation of a real project requirement in which we want to see the statistics of the transactions happening at the regional level in real time at the client end. So this is all about the Snowflake streaming feature. If you find this video helpful, please like it and subscribe to my channel. See you in the next video.